All right, hello everybody. Today we're going to continue to talk about how we can solve log equations, but we're going to also incorporate the use of the properties of logs. But before that, let's just go ahead and do a quick few warm-up questions from what we talked about last week. I know it's been a while since we did these. Okay, so let's take a look. 12 to the negative 4n minus 3 plus 3 equals 11. So let's go ahead and subtract 3 on both sides. We want to get this guy by itself. So we have 12 to the negative 4n minus 3 equals 8. Okay, and now what we want to first think about is how if we can change our bases to be the same. But in this case, I don't think it will work with 12 and 8. So let's go ahead and rewrite this in log form. So we have log base 12 of 8 equals negative 4n minus 3. Again, you can always use a circle method to kind of double check to see if you did that correctly, right? We should have 12 to the negative 4n minus 3 equals 8, which is exactly what we have. And then let me write this on this side. And now the left-hand side, you can use your calculator to evaluate. You can just type this in, log of 8 over log of 12. And you should get negative 4n minus 3 is equal to 0.837. And then add 3 to both sides. Let me go back over here. Negative 4n is equal to, I got 3.837. And then, of course, divided by negative 4. So your final answer should be negative 0.959, and there it is. Okay, and of course it's always a good idea to check your work, which I can do up here. So the goal is just to plug in our value for n. So plug in negative 0.959 minus 3 and then plus 3. I should get 11. In this case, if you just type that to your calculator, I think it will work out. And then, by the way, I should mention that as you watch this video, make sure you're taking notes either in your notebook or if you have a printer at home, you can also print this from my calendar, and then you can just kind of follow along as I'm doing these. Okay, and then let's go ahead and go through the second one. And then again, we want to get the log by itself. So let's go ahead and first add 3 to both sides. So I get negative 12. It's divided by negative 6. So I have log of 5a plus 5 is positive 2. Okay, and now once we get to this step, I think a couple of you were asking me about this via email. So now this is where you want to rewrite this in log form. So we know this is base 10 because there's nothing written there, so that's implied. And now if we do it this way, we end up with 10 squared is equal to 5a plus 5. And now this is something that we know how to solve. We get 100 here, 5a plus 5 minus 5 on both sides. I get 95 equals 5a divided by 5. Looks like I get a equals 19 as my final answer. Again, let's get into the habit of checking your work. So I'll do it up here, check. So negative 6 log 5 times 19 plus 5 minus 3 equals negative 15. And again, to check, you can just use your calculator. If you're typing the left-hand side, you will end up getting negative 15. So in this case, this works as well. Okay, so now let's go ahead and kind of move on to how we can solve using the properties of logs. Again, this is nothing new actually, but let's just go ahead and kind of do a quick summary of our properties. So first we have the product rule, and remember that says if we have log base x of a, and then if I add it to log base x of b, you can actually combine those two by doing log base x of a times b. And then similarly, we have the quotient rule. If you have log base x of a minus log base x of b, and then here we can rewrite as log base x of a divided by b. Okay, so those are the two rules that we're mainly going to use, the product rule and the quotient rule. There is also what's called the power rule. We also talked about that. So that says if I have log base x of a to the power of b, you can rewrite this by moving the exponent down as a coefficient, like so. This one we won't really use as often when we're solving, but it's something that we talked about as well. So hopefully this looks familiar to you. And then we'll just go ahead and do a couple of examples to see how we can use the property. So for example, over here, if I have log base 5 of x minus 10 minus log base 5 of 9 equals 1. Well, notice how on the left-hand side we have these two log base 5s. So then we can actually use the quotient rule, right? So that says if it's the same base and they're being subtracted, we can actually make it division and under 1 log. Okay, and now this is something that, we saw from before, where we can simply go ahead and, do this, put it into the other form. 5 to the first power is x minus 10 over 9. 5 to the first power is just 5. And then to get x by itself, right, because that's always the goal, to get x by itself, we can times 9 on both sides. I get 45 equals x minus 10 plus 10. So it looks like I get x equals 55. But again, it's always a good idea to make sure you check your work. So I can do that over here. So log base 5 of 55 minus 10 minus log base 5 of 9 equals 1. Over here, I get a positive number. I get a 45. So that's kind of how you know that it's going to check out. And if you use a calculator, you'll see that, this will be the same on both sides. Okay, so really, there's nothing really new here. We're just kind of combining our properties of logs with our techniques of solving equations that we saw last week. So kind of moving on, very similar over here, except we have a plus. So then instead of the quotient rule, we're going to use the product rule. So then what we can do is we can actually multiply those two guys. So x plus 5 times 2 equals 1. And then let's actually go ahead and distribute the inside. Distribute over here. So I should end up getting 2x plus 10, it looks like, equals 1. And then again, same as before, let's go ahead and use the change of base, or rather rewriting. So I get 9 to the first power, which is just 9, 2x plus 10 minus 10. I get negative 1 here. And it looks like I get x to be negative 1 over 2. Again, make sure you just check your work. So if we do log base 9 of negative 1/2 plus 5, and then if I add it to log base 9 of 2 equals 1, again, I think I'm going to get a positive number here, negative 1/2 plus 5. So that's going to check out. The only case where we have extraneous solutions, remember, is if you have a negative number on the inside, or if you have 0, because those will not be defined. And we'll see examples of that in these last couple. Let's just try a couple more. If you like, you can actually pause the video and then try them yourself, and then kind of double check with me to see how you did. This one is actually slightly different, but the idea is the same. Same thing. We can use the quotient rule on the left-hand side because they're both log base 5. And now we have log base 5 on both sides, actually. So we can actually, I think we talked about this as well last week. We can actually just set these equal to each other, right? Because if these logs are the same, if these are the same, then whatever is inside the parentheses must be the same as well. So we must have 4x minus 3 over 4 equals 23 times 4 on both sides. I think that's 92 plus 3 plus 3. 4x equals 95. Divided by 4. And this time we wound up with a fraction, which is okay. Here it is. And then, of course, still same thing. Check your work. So if I plug in log base 5 of 4 times 95 over 4 minus 3 minus log base 5 of 4 equals log base 5 of 23. Again, I think I'm going to get a positive number here, so I think it will turn out to be okay. You can always use a calculator to double check. That's always the quickest way. All right, couple more to go. Again, I think this one was pretty similar to the one we just did. We can use quotient rule on the left. N plus 2 over n plus 6 equals log base 4 of 3. Same thing, we have the log, same base for the logs. So then whatever is highlighted I just did there has to be the same. N plus 2 over n plus 6 equals 3. And now there's a couple of ways we can do these, right? This is divided by n plus 6, so then we can multiply both sides by n plus 6. So then I get n plus 2 is equal to, again, over here, make sure you distribute 3 times n and 3 times 6. Looks to be 3n plus 18. And then again, this is something we know how to solve. Let's subtract n on both sides. Let's also subtract 18 on both sides. So I get negative 16 equals 2n divided by 2, n equals negative 8. Okay, once again, we're not done just yet. Go ahead and check your work. And now let's take a look. So log base 4 of n plus 2, well, n is negative 8 plus 2 minus log base 4 of negative 8 plus 6 equals log base 4 of 3. Now, what we notice is this number and this number actually both turn out to be negative. So, and we know that we can't take the log of a negative number. So these are actually undefined, right? Because I get negative 2 here, I get negative 6 up top. I get, right, this will turn to be negative 2, this will turn to be negative 6. And both of those are undefined, which means if we go back over here for n equals 8, we call this an extraneous solution. Okay, but let's go ahead and make sure we mark that up. Extraneous, because it was undefined after we plug it back into the equation. All right, last one. Okay, log base 6. Again, we can use product rule here, so we can multiply what's on the inside. Let me go ahead and distribute that. So it looks like x squared plus 5x equals 2, using the distributive property here. And then again, once we get over here, if we have a log on one side, we can use the circle method. 6 squared is x squared plus 5x. 6 squared is 36, so let's get that on the right-hand side. X squared plus 5x minus 36. And now this is a quadratic, which we know how to deal with. You always want to look for, to see if you can factor, adding up to 5, multiply to negative 36. So it looks like we get x equals negative 9 and x equals 4. But we should go ahead and check each one to see if either one is extraneous. So what do we have? We have x equals negative 9. So let's go ahead and check that first. Okay, x equals negative 9. So plugging into the equation, I have log base 6 of negative 9 plus 5 plus log base 6 of negative 9 equals 2. Again, we see that we end up with a negative number here and here. So that tells us that this is actually undefined. So let's go ahead and write that, undefined, which means for x equals negative 9, If we come back over here, we get an extraneous solution. And then we should check the other one as well, x equals 4, to see if that works. So if we plug it in, log base 6 of 4 plus 5, that looks good, plus log base 6 of 4, that looks good, equals 2. In this case, we get a positive number, we get a 9 here, we get a 4 here, so those are okay. So this is gonna end up checking out. So x equals 4 is the solution, but x equals 9 is extraneous. Okay, so that is really it in terms of solving with log equations. Again, really it was nothing new, but we're just combining the use of properties with the techniques of solving that we saw last week. So hopefully you're taking notes. Please make sure you're copying down these examples and then try the homework. And yeah, thank you for watching. Hope you have a good rest of your day.